this we have studied types of lenses, types of concave lens, types of convex lens, and after that we have studied uses of the lenses. Later on in the last part of the lesson we are going to study in detail what are the uses of the concave lens, what are the uses of the convex lens. Now we are going to study some terms related to the lenses, as like we have seen terms related to the spherical mirrors. Now we are going to study about terms related to the spherical lenses we are going to study. So before that we'll compare that two lenses. Suppose you will take, suppose this one you will take first convex lens. So convex lens is having two spherical surfaces bulging outward. So this one will be the convex lens. And if you will draw imaginary circle like this way, if you will draw imaginary circle, then here will be one circle, its center of curvature will be there, C1. If you will draw another imaginary circle, then its center of curvature will be, suppose C1 is here and C2 is here. Suppose this one is the sphere S1 and this one is the sphere S2. So two spheres are there, and this surface is of this S2 sphere, this surface is of this sphere S1. Again one more thing is that if you look here, midpoint will be there, midpoint of the lens, it will be the optical center, and you will join this line, it will be you can say that one is principal axis, and here middle, here will be F1, here will be F2. Principal focus of first sphere, principal focus of second sphere. That means principal focus you can take. Then suppose you will take this one will be R1. Suppose you will take this one will be R2, So two spheres are forming. Suppose you will take one convex lens, it is made up from the two spheres, and that parts are there. This surface is there, part of this sphere, and this surface is part of S1 sphere. So like this way you can say each lens is having two centers of curvatures, that is C1, C2 are there. Again you can take each lens is having two focus, F1 and F2. Again third one is there, it is having optical center, at the middle. And fourth one is there, it is having what you can say, radius of curvatures, R1 and R2, two radius of curvature. Again it is having one principal axis, So like this way is the lens. If you consider another concave lens, then it will be like this way. Now concave lens. So in case of the concave lens, like this way lens will be there, and if you will draw imaginary circle, this one will be also imaginary circle, and here will be optical center O, and this is part of the sphere. Suppose this one is their S2 sphere, this one is their S1 sphere, then here center of this S2 is there, C2, suppose center of this S1 is there, C1 is there, and the line joining to both, it will be a principal axis, Again one more thing is there, suppose here will be principal focus F1, here will be principal focus F2, and this one will be radius of curvature R1, and also you can take this one will be radius of curvature R2. So like this way, same points are there for each lens, and you can say there are C1 and C2, two centers of curvatures. Second one R1 and R2, two radius of curvature. Third one is there optical center is there, optical center is there, O at the middle. Next one is there you can take F1 and F2, two principal focus are there, principal focus are there. And fifth one you can take principal axis is there, principal axis, and that principal axis it is joining the two centers of curvatures, it is joining the two centers of curvature. So this one is the about the lenses, convex lens and concave lens, and they are forming two imaginary spheres. Now after this we are going to study some terms related to the spherical lenses in case of the lenses, and that terms one by one we are going to study. I will have this one. So what are the terms related to the lenses, that one will see. So first term is there center of curvatures. So terms related to lenses. Which are the terms related to the lenses? First term is there also diagrams also will draw. Okay, small diagrams will draw, and then also will take. So when I am going to explain optical center, at that time I will draw the diagram. So first one is there, suppose first one is the center of curvature. Center of curvature. Here a diagram is necessary, so we'll draw one diagram like this way. So optical center will be there. Again this is the lens. So if you will draw imaginary sphere like this way, then here will be C2. If you draw imaginary sphere this way, then here will be C1. So line you are joining, middle one line you are passing from C1 and C2. That one will be the principal axis, that line will be the principal axis, and O will be the optical center. O will be the optical center. So like this way you will draw. So first term we have to study center of curvature, and it is denoted by letter C. It is denoted by capital letter C. So you will say definition. So the center of spheres, of which lens is a part is called centers of curvature, or center of curvature you can say. So another definition also you can write. So spherical surface, okay, center of the spherical surface of lens, center of the spherical surface of the lens. So center of the sphere whose surface is a part of the lens, Second definition is there, centers of spheres. Suppose two spheres are there. Suppose this one is the S1 and this one is the S2. So centers of these spheres of whose parts are forming surfaces of lenses. So centers of spheres of whose or whose parts forms surfaces of lenses are called centers of curvatures. Centers of curvatures. Centers of curvatures. So another thing is there, important thing is that each lens has two centers of curvatures. So each lens, so you have to take each lens means double convex or double concave. Each lens means double convex or double concave. Each lens has two centers of curvatures. And these are C1 and C2, two centers of curvatures. So this one we have taken for a convex lens. For concave lens is also same diagram will be there. We have drawn that diagram before this. Then second term is there. Radius of curvature you can take. Radius of curvature, and it is denoted by the letter capital R. Radius of curvature. So same definition you can do. Radius of spheres or radii of spheres whose parts form surfaces of the lenses. These are called as the radius of curvature or radii of curvature. So radii of curvatures, radii of curvatures, radii of the curvatures of radii of curvature are the radius or radii of spheres whose parts forms surfaces of lenses. Radii of curvatures are the radii of the spheres whose parts form the surfaces of lenses. So suppose from here one radii will be there. Suppose this one R1 is there, so R2 is there, and it will form from here. It will be R1 will be there. So radii of curvatures are the radii of the spheres whose parts forms the surfaces of lenses. It is called as the radii of curvature. And another thing is that each lens has two radii of curvatures. Then next thing is there. Next term you can take. Third term we are taking, and that one is there. Optical center. Now in case of the mirror we have seen we are taking pole of the mirror we are taking, and now here we are taking optical center, and it is denoted by the letter O. And for that we are going to draw two small diagrams, and these two diagrams are there. Suppose you will take one convex lens, optical center will be there. Then here will be C1, here will be C2, and then line joining, it will be principal axis. Then here will be first principal focus, here will be second principal focus. So suppose first light ray, one light ray you are taking like this way, it is going straight. Another light ray you will take like this way, it is passing through the optical center. So suppose you will take P1, Q1 you will take, here you will take P2, and here you will take Q2, here you will take P3, you will take Q3. Again, if you will take another diagram, that is a concave lens you will take, then also here will be optical center O will be there, here will be C1, here will be C2, then a line joining will be there, the line joining will be principal axis. You have to draw diagram with scale. Again, first light ray it will take like this way, it is, sorry, first light ray you will take, it is passing to the optical center you will take, then suppose this one will be P1, Q1, another light ray you will take passing through the optical center, suppose you will take P2, Q2, then here P3, Q3 will be there. So now we have to do the definition. So how we will do the definition? Midpoint of the lens, or center of the lens, midpoint or point at the center of the lens, inside the lens, from which light ray travels without any deviation or without any without changing the direction, you can say. So definition will write here, optical centers definition we are going to write here. So that definition will be there. 1 minute. Optical center. Optical center. So in that optical center, the point at the, or a point inside the lens, point inside the lens on the principal axis, on the principal axis, on the principal axis, point inside the lens on the principal axis, through which incident light rays travel without changing their direction, is called optical center, is called optical center of the lens. And each lens is having only one optical center, that one you have to remember. Fourth term is there, principal axis. So what is principal axis? The straight line joining two centers of curvatures, or straight line passing through, straight line joining to two centers of curvatures, and it is passing through the optical center, it is called as a principal axis. A straight line passing through two centers of curvatures, two centers of curvatures is called principal axis, or also you can say a line joining two centers of curvatures, it is called as the principal axis. And here, which is the principal axis? PQ will be the principal axis, P3, Q3 will be the principal axis. Then next term is there, next term we are going to draw, define, and that term is there, principal focus. That next term is there, principal focus. So for that I will give definition for principal focus, both So I will rough all these and then we'll draw diagram and we'll take next term. So principal focus. So what is the principal focus? Separate we'll do definitions for concave lens and convex lens. So next term. Center of curvature, radius of curvature, optical center, principal axis. Now fifth point is there, principal focus. Principal focus. So, and it is denoted by capital letter F. And each lens is having two principal foci or focus. So in that first we'll draw the diagram for the convex lens. For convex lens, suppose you will take one convex lens. Here will be optical center. If you will draw imaginary circle, here will be C2. If you will draw this side imaginary circle, here will be C1. And now line joining to both and passing to the optical center, it will be the principal axis. So this one will be principal axis. Then this one will be optical center. Now light rays which are coming parallel to the principal axis, after refraction, they are meeting at single point, or they are passing to the single point. So it is called as a principal focus. So light rays coming parallel to the principal axis, after refraction, they are meeting at single point on the principal axis. At the single point on the principal axis. It is called as a principal focus. So the point on the principal axis where light rays, or wait 1 minute, we'll do another way. So principal focus, the light rays parallel to principal axis after refraction meet at single point on the principal axis. Is called principal focus of convex lens. So you can say another way also, the point on the principal axis where incident light rays coming parallel to the principal axis meet at single point after refraction on the principal axis. It is called as a principal focus. So light ray parallel to the principal axis after refraction meet at a single point on the principal axis. Is called as the principal focus of the lens. And each lens has two principal focus, that is F1 and F2. If you take light rays from this side, they will meet here also. So like this way. And for concave lens, so we will draw the diagram of the concave lens. Like this way will be the diagram. So here will be optical center, imaginary sphere, here will be C1, imaginary sphere here will be C2, and the line joining will be the principal axis. Again, optical center. So light rays which are coming parallel to the principal axis, after refraction they will get diverged, they will get separated, they will move apart, they will get diverged. So, but if you will extend them backward, they will meet. Suppose here F1 is there and here F2 is there. So it is the point on the principal axis, where light rays appear to be coming from, or they are, if light rays are coming parallel to the principal axis, after refraction they get diverged, but they appear coming from a point, from a single point on the principal axis. It is called as a principal focus. The light rays parallel to principal axis after refraction get diverged, but appear like coming from a point on the principal axis, is called principal focus of concave lens. So here light rays after refraction they will get diverged, but they appear like that they are coming from the point F1, they are coming from a point on the principal axis. So it is called as a principal focus. And here also it is having two principal focus, F1 and F2. So these points are clear. Now after this, next thing we are going to study, one thing you have to remember, principal focus. Okay, principal focus. In case of the, we are going to study sign convention, in that it will be clear. So these terms you have understood. Now next term we have to study, and that one is there. Next term is there, focal length. So just diagrams I will give that one, and then I will write the definition. Diagram will be same, no problem. Diagram is same. On same diagram all that explanation is there. So next term is there, focal length. Sixth term is there, focal length, and it is denoted by small letter f. So the distance between optical center and focus, this distance, it is called as a focal length. The distance between optical center and principal focus is called focal length. Same definition is there here also. The distance between principal focus and optical center, it is called as a focal length. And one thing you have to remember, most important thing is that focal length is half of the radius of curvature. That is, focal length is equal to r upon 2. Also you can say r upon 2. Radius of curvature, its half is the focal length. So this side focal length will be there, radius of curvature, whatever will be the R1 will be divided by 2. Here will be R2 divided by 2. So these are the terms related to the lenses. And after this we'll in latter part we'll see which is the converging lens, which is diverging lens, and their images form and rules we are going to study. So convex lens is their converging and a concave lens is their diverging. You have to remember this one.